This module starts out talking about kinetic energy, which we've talked about before in this course and in some of the other classes that you've taken. Kinetic energy, as you might remember, is that energy of movement. Well, now we're going to be linking that energy of movement to movement of molecules within substances. So within solids, liquids, and gases, and how those molecules react to different variables. Specifically, we're going to be looking at temperature, pressure, and volume. I'm going to share my screen with you, and we're going to look at a little simulation. The simulation is a PhET simulation, and I will give you the address in case you want to play around with it, the web address, that is. So this is the PhET simulation that I was talking about. And you can see at the top of the screen up here, the web address, if you would like to. If you go into just phet.colorado.edu, there's lots of simulations for science. We'll be using a lot of them throughout the year. But this one applies to this module really nicely. So in this particular situation, we can change pressure, volume, and temperature on these particles. Now the particles are moving around quickly, bouncing off of one another. And that's what kinetic energy is all about. So if I come over here and I hit the collisions, the number of collisions to the walls, as we have our standard set up right now, it's 595 collisions. Okay. Now, if I reduce the pressure by increasing the volume, or here I can increase it a little bit more, I think. Okay, so when I increase that volume, the pressure automatically reduces. So if you watch that pressure gauge, I'm going to increase the volume a little bit more, and it should come back down. Okay, so you can see it's dropped a bit. Now let's take a look at the number of collisions. So remember, we were at 595. Okay, and by increasing the volume, we reduce that to 467. The pressure has also decreased. So let's take a look at if we cool our substance down. So we're going to cool it. Oops, I'm sorry. Cool it down, sit our container on some ice maybe, take a look not only at that temperature, but also look at how the pressure is decreasing as we decrease temperature. So we have a direct proportion there. Okay, I'm gonna quickly hit the wall collisions so we can see how many collisions we have at lower temperatures, only 114. All right, shall we heat things up a little bit so we can see what happens? All righty. Should have the opposite effect. As you can see, as we heat up our substance, those molecules start to move more quickly. The kinetic energy is increasing, temperature is increasing, as is the pressure. Eventually, the pressure gets to be too much, and I think we can blow the top off. Okay, so the pressure got to be too high and the lid blew right off of the system. But as I said, you can play around with this. It's a lot of fun to play around with. You can change the variables, you can keep things constant so that you can see which variable has the biggest effect. And I think as you get into the module, it'll definitely help you when you start having to answer some of the questions and use the equations that go with this. I'm just going to copy this link for you. And I'll stop sharing. I'm going to put this into the chat. Now that's not going to work because you're not watching it live. I will put this up in the module for you. Okay, well, I hope you enjoyed that simulation. This module actually is a lot of fun with the gas laws, and I hope you enjoy it. If you have questions, as always, just reach out. Take care.